What's up, guys? So, you clicked on this video. It means that you have an amp overheating problem. Now, what causes an amplifier to get hot? Well, there's a lot of things that can cause it to heat up. Number one, an amplifier doing its job is just going to get warm, especially if it's an older Class AB amplifier. They're very inefficient and they turn a lot of the energy they take in into heat. And because you're changing direct current from your battery into alternating current and then sending that out to your speakers. Anytime you change one type of energy into another type of energy, you have losses. Those losses always wind up being heat. Um, but we're not going to get into thermodynamics and all of that stuff. You just want to know why your amp's getting hot. Well, a couple of things will cause it. One of them is ground issues or loose connections at the amplifier itself. If the connection at the amplifier is loose, or if you're using too small of a wire, that generates resistance, which generates heat. That heat can transfer into your amplifier. It's probably not your problem, though. It is a possibility. Most likely culprit is going to be lack of power. See, the way you turn DC current or DC voltage, power, direct current into alternating current is simple math. So you're inputting amount of power and you're outputting power. You take your amperage that you're bringing in and you multiply it times the voltage that it's running at, and that gives you the wattage minus a percentage of heat. Okay, so you got 12 volts. Well, we'll say you got 14 volts coming in, and you're needing to make 1,000 watts of power for your amplifier. To make 1,000 watts of power at your amplifier, you're going to need to make about 1,200 watts consumption because you're going to lose about 20%. That's if you got a good amplifier. You're going to lose about 20% of that power coming in when you change it over. So if you need 1,000 watts of output, you need to accommodate for 1,200 watts, which means you need to bring in 12 volts and 100 amps. And 12 times 100 is 1,200. Okay. That's how you get the wattage. So if you're bringing in 14 volts, you need less amperage to get that 1,200 watts. You see how this works? Now, if your voltage is coming in and it drops down to 10, 11 volts, even if your amplifier is still able to play at that low of a voltage, you're now having to pull a lot more amperage to keep up with that, which means the amplifier itself, the device, has got a lot more amperage, a lot more current running through it. When you add all that current, what happens? It generates heat because it's going to need more conductors, more of a conductor to move through it. So it's going to generate heat. Heat generates resistance. Resistance generates heat. Generates resistance, generates heat. Rolling, 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 rolling. So as your amplifier starts to heat up, it becomes less efficient, generates even more heat. The culprit in this scenario is the fact that you're trying to get too much power out of the amplifier versus how much power you have going in. And knowing my fellow bassheads out there in the world, you're almost definitely trying to pull more power out of the amplifier than you're putting into it, and your voltage is dipping. And your voltage starts to dip, even if it's still above 12 volts, even if it's still safe. As that voltage goes down, the amperage goes up a lot. Okay. So if you're noticing the heat when your voltage is dropping, even if it's staying above 12 volts, that's the reasoning why, is you're pulling more current. And of course, like I said, it snowballs and it keeps increasing. And not only does this get the amp hot, but this can also do long-term damage, if not immediate damage to your equipment. Um, you also melt fuse holders and things like that. Um, you may not be pulling enough current to blow the fuse, but that may be because you have too big of a fuse in that system. So that's not really going to happen. But still, they're pulling enough current to generate a lot of heat. And the trick to stopping that is, like I said, more power, baby. You need a bigger alternator. Here's the thing. No matter how much boom you can get, how loud your system gets on your stock system, whatever, it takes power to make power. So if you're running on, 140 amp alternator and you're got a 2000 watt amp hooked up, yeah, the 2000 watt amp is going to make bass. It's going to turn what available power it has into bass. It's going to go boom, boom, boom. It might run all day long. But the most power you're going to be able to get out of that system constantly is what the alternator has left after it runs the car. Usually a stock alternator is using about 60 to 70% of its output just to make the car run and operate all the stuff. What that means is you've got on a stock 160 amp alternator, you may have 60 amps left over, which means the most you can continually pull out of your 2000 watt amplifier is about 600 watts. That's just how it works. You can't make something out of nothing. It doesn't work that way. Now, can you get a boom, a 1200 watt boom? Yes, you can go boom and then back off, let the alternator charge the battery back up a little bit, and then go boom again. In that case, about 50% of the time, you can get 1200 watts, but you're still not getting that 2000 watts. And you're also stressing out that amplifier and making it pull current and try to make the wattage it's trying to make. And that's going to cause it to get hot. This is why your amp overheats. Even if you're only running it at half volume, you're still pulling more power or trying to pull more power through there than your charging system can keep up with. So start at the amplifier, follow the path of the hot path and the ground path all the way back to your charging system. If you got a ground wire that's connected to the body, follow that connection all through the car. Look for any spot where it might not be that thick of a connection. Make sure those connections are good and tight. Make sure you've got plenty of wire to be able to carry the current from the alternator all the way to the amplifier. So if you got a short piece, a little stubby piece of wire that's breaking the system down somewhere in that system, you need to add to it or replace it. Get that path for that power from the alternator all the way to the battery, all the way to the amplifier on power and ground. Make sure all those connections are tight and there's plenty of material for that to conduct that electricity. Make sure your alternator is putting out enough power after powering the car to be able to power the amplifier. Those are things that are going to stop the heat buildup. Those are things that are going to improve your overall system performance. And all the problems that you have, these things will fix those problems. If you want to make power, you got to spend money. It is what it is. I don't make the rules. I'm just dropping it on you, man. So if your stuff's getting hot, most likely you got power problems. Peace, guys.